All right, y'all, let's do absolute value inequalities. Let's review really quickly the graphing of inequalities. So the first thing you want to do is decide whether it's an open or closed circle. We did this a bit with graphing linearly with like the dashed line or the solid line. But here, we're just going to find out if it's open or a closed circle. Then we want to plot the circle, use a test point to decide which way to shade, and then shade the correct side of the number line. So let's look at our first example down here. It's pretty clear that the circle should go on the number 4. Is it open or is it a closed circle? Well, it matches. It's one of my x's greater than or equal to 4. So it's definitely going to be closed. Imagine that's closed. It's kind of hard to do on here. Plot the circle, use a test point. I think most of the time, almost all of us are going to use 0 whenever we can. It just needs to be a point not on the number 4. All right, is 4 less than or equal to 0? No, it is not. So it is definitely going to be this way. If I do one more point just to make sure, is 4 less than or equal to 6? Yes. So I know that it's going to be to the right. Number 2 here, a is less than 1. We're definitely going to the number 1, and it's going to be an open circle because it does not have an or equals to portion of it. Let's use 0 again because we can. Is 0 less than 1? 0 is less than 1. So it's probably going to be this way. Let's check on the other side just to make sure. Is 3 less than 1? No, it is not. All right. So hopefully that is review for you on how to graph inequalities here. An absolute value inequality is just an inequality with an absolute value in it. So just like we've been doing before, like the absolute value of x minus 4 equals 6 or whatever, and we have two answers here. It's just an inequality, and we're going to follow the same rules that we have for other inequalities, except for there's an absolute value in place. Here are the steps to solve absolute value inequalities. It's very similar to our other steps for solving absolute value equations. However, there's a couple things we need to make sure that we separate from that. So we want to isolate the absolute value, just like we did. Split the equation into two equations, one with a positive, one with a negative result. However, it is imperative that we remember we need to flip the inequality symbol of the negative result. I'll show you that in an example. Solve both inequalities and graph them both on the same number line. Let's just skip to an example. Example 1. Solve and graph 3 times the absolute value of 6x plus 1 is greater than 39. Well, let's isolate it to start. We're going to definitely divide both sides by 3 to get that absolute value by itself. 6x plus 1 is greater than 39 divided by 3 is 13. We don't need to flip the inequality yet. If we had divided by a negative 3, we would have. But for now, isolating the absolute value of 6x plus 1 is greater than 13 is just fine. Now we want to split it. We want to keep 1 as positive. 6x plus 1 is greater than 13. And on the other side, we are going to do our magical thing. I'll pick a different color here. 6x plus 1 is less than negative 13. We have to flip that inequality for the negative result. All right, so let's solve the one on the left. Go back to green. Subtract 1 from both sides. 6x is greater than 12. Divide by 6. And we're left with x is greater than 2. If we want, we can graph that one first. Actually, let's do that. Go down. Is it an open circle or closed circle? You all said open. Very good. X is greater than 2. Is 0 greater than 2? No, it is not. X is greater, so it's going to go out from here. All right, let's jump to our negative 1 here. Subtract 1 from both sides. We're left with 6x is less than negative 14. Divide both sides by 6. We're left with a fraction here. Negative 14 sixths Probably would be good to simplify that. They are both even numbers. So I'm thinking we'll make that negative 7/3. Yeah, that's a little bit better. Negative 7/3. Now, how do we plot that on the graph? What do we do from here? Wait, how are we supposed to do this? That's not fair. We have to use our best judgment here. We know that negative 6 divided by 3 would be negative 2. So we're going to go a little further than that. It's not quite half. It's probably like right about there. Is it an open circle or closed circle? It's open. Now, let's see if we should go left or right. Let's use 0 again. Is 0 less than negative 7/3? No. 0 is greater than. Okay? So we're going to be going outwardly this way. It won't always work out this way, where there's a gap in the middle. There's a lot of answers that can go into this absolute value. However, everything inside in the middle there is definitely not a solution here. But there's many, many, many solutions outside of that. Let's go to another example. Oh, that kind of looks funny. Let's fix that absolute value line that seems to have disappeared. There we go. Solve and graph negative 4 times 2x times the absolute value of 2x minus 5 plus 5 is greater than negative 23. I've seen some tendencies to want to distribute into the absolute value. Remember that although when it's squished together, we are multiplying that, we don't want to distribute. We want to isolate first. That's our number one goal. We could divide everything by negative 4, but that's going to be a bit messy. I think we should subtract 5 to start in order to isolate. And that leaves us with negative 4 times the absolute value of 2x minus 5. And that would equal negative 23 minus 5 is going to be, oh my gosh, I'm blanking, negative 28. Here we go. Once I've got that, I'm going to divide everything by negative 4. And if I'm dividing by a negative symbol, I definitely need to flip my inequality. I remember that. 2x minus 5 absolute value is less than 7. All right. We've definitely isolated our absolute value, and now we need to split. I'm going to rewrite that. Okay. On the left, I have my 2x minus 5 is less than 7. It's just the way it was a moment ago. However, on the right, I have made it negative 7, and I have flipped the inequality. 2x minus 5 is greater than negative 7. All right, so let's solve the left one first. Adding 5 to both sides is going to get me to 2x is less than 12 divided by 2. Don't need to flip anything. Everything should be good as is. X is less than 6. So I go to 6, open circle. 0 is less than 6, so I know that it's going to go that way. I'm not going to completely fill out the whole thing yet because I want to see what the other one does before I do that. Over here, 2x minus 5 is greater than negative 7. Add 5 to both sides. I'm left with 2x is greater than, what would that be? Add 5. Negative 2. Divide both sides by positive 2, so I don't need to flip anything. X is greater than negative 1. X is greater than negative 1. Is 0 greater than negative 1? Yes. So I got an open circle here, and then I'm definitely going to the right. So that arrow those lines do not go forever. It's actually going to be just one line here. Everything between negative 1 and 6, not including those numbers because it's not or equal to, is our solution on the graph. Everything outside of those parameters is not a solution that will work here. All right. I think that's it. Is there another slide? Nope. Please head to the try it problem, and we'll see you in class.